So you've dug yourself a hole in the ground. Congratulations! You're now the proud owner of what engineers would call a dirt cavity with delusions of grandeur. Maybe you thought it would be easy. Maybe you watched too many Cold War documentaries. Maybe you just really hate your neighbors and wanted an excuse to avoid them permanently. Whatever your reason, you're now standing in what is essentially a very committed grave. And you've realized something important. Dirt has this annoying tendency to obey gravity. Those walls you were so proud of, they're looking at you with what can only be described as malicious intent. They're plotting, they're waiting, and one heavy rain later, you're going to be playing a very unfortunate game of guess which pile of mud used to be my sleeping area. But here's the good news. You don't need an engineering degree or a trust fund to fix this problem. You just need some scrap materials, basic physics, and the willingness to accept that yes, you are absolutely the kind of person who reinforces underground shelters now. Welcome to the club. We meet underground, obviously. Let's talk about lateral earth pressure, which is a fancy way of saying dirt pushing sideways, really, really hard. When you dig a hole, you're removing all the dirt that was previously supporting all the other dirt. That other dirt is now very confused and slightly angry. It wants to return to its natural state, which is filling in any available space, and unfortunately, you're standing in that space. Think of it like this. Imagine you're at a crowded concert, packed shoulder to shoulder. Now imagine someone carves out a little bubble around themselves. What happens? Everyone immediately crushes inward to fill that gap, probably while spilling beer on each other. Your underground shelter is that bubble, and the surrounding earth is thousands of drunk concertgoers made of soil and rocks. The deeper you go, the worse it gets. Every foot down adds more weight pressing from the sides. At 6 feet deep, you're looking at roughly 300 pounds per square foot, trying to give your walls an unwanted hug. At 10 feet, nearly double that. Your walls aren't just dealing with a gentle nudge. They're in a structural wrestling match, and right now, they're losing. Now add water to this equation. Water is the ultimate traitor in underground construction. It seeps into soil, adds weight, reduces friction between particles, and basically turns your stable dirt walls into what I can only describe as aggressive pudding. Clay soil expands when wet. Sandy soil loses all cohesion. And if you're unlucky enough to have built-in loam during spring thaw, well, I hope you're good at swimming through mud. This is why ancient civilizations figured out reinforcement pretty quickly. The moment someone dug a storage cellar and watched it collapse on their turnip collection, humanity collectively decided that maybe putting some wood or stone in there wasn't such a bad idea. Let's inventory what you're working with, because I'm assuming if you're reinforcing a shelter with scrap materials, you're not exactly shopping at the boutique structural supply store. You're probably eyeing that pile of weird junk in your yard that you've been meaning to deal with for 3 years. Wooden pallets, the cryptocurrency of the post-apocalyptic economy. These things are everywhere. They're usually free, and they're basically pre-made wall panels. A standard pallet can handle a decent amount of compression if you orient it correctly. The key word here is correctly, because if you just throw them against your wall like you're playing the world's worst game of Tetris, you'll achieve absolutely nothing except giving the dirt some wooden toothpicks to laugh at. Here's what you do. Stand them vertically against your walls, slats facing inward. This creates a gridwork that distributes pressure across multiple points rather than one continuous surface. The gaps between slats actually work in your favor because they allow for minor soil movement and drainage without catastrophic failure. It's like giving your wall permission to breathe, which sounds ridiculous, but structural breathing is absolutely a real concept, and I'm not making this up. Old doors. Solid core doors are essentially engineered wood panels, and they're brilliant for this application. They're flat, they're strong, and they come in convenient, human-sized dimensions. Place them vertically against your walls, and suddenly you've got a smooth, solid surface that says, I am a functional wall, instead of I am a future archaeological curiosity. Car hoods and metal sheeting. Now we're getting industrial. Metal doesn't compress, doesn't rot, and laughs at moisture. The downside? It's cold. It conducts temperature like nobody's business. And if you don't handle it right, you'll end up with edges sharp enough to perform impromptu surgery. But for pure structural reinforcement, a car hood placed vertically creates an excellent barrier. Just make sure you're not using something so thin it buckles under pressure. If you can dent it with a firm poke, it's not going to stand up to several tons of earth. Concrete blocks, bricks, and stone, the classics. These have been holding back dirt since before dirt had a name. Stack them properly, and you've essentially built a retaining wall underground. Stack them improperly, and you've created an elaborate domino setup that will collapse in the most entertaining way possible at the worst possible moment. Corrugated metal roofing. This stuff is designed to span distances and handle loads, which makes it perfect for roof reinforcement. The corrugations create structural ridges that resist bending. Lay it across your ceiling joists, and you've just upgraded from ceiling that might collapse to ceiling that probably won't collapse, which is a meaningful improvement. Tires? Yes, tires. Filled with compacted earth or gravel, they become incredibly strong structural units. Stack them, interlock them, and you've got a wall that can handle absurd amounts of pressure. This is literally how some erosion control systems work. The rubber is durable, weather-resistant, and free if you know where to look. The only downside is explaining to visitors why your shelter looks like it was designed by a monster truck. Let's build a reinforcement system that won't immediately fail and make you the star of a very sad local news story. Start with wall reinforcement. You want to create a system that transfers pressure from the soil into structural members that distribute that load. Think of it like this: unreinforced wall equals pressure concentrated on dirt, which compresses and fails. Reinforced wall equals pressure distributed across rigid materials, which push back and create equilibrium. Step 1. Vertical support posts. Find sturdy wooden posts, metal pipes, or anything that can handle vertical compression. You want something at least 4 inches in diameter. Sink these into the floor of your shelter every 3 to 4 feet along your walls. These become your primary load-bearing elements. Everything else attaches to these. Step 2. Horizontal bracing. Attach your wall materials to these vertical posts. If you're using pallets, secure them with bolts or heavy-duty screws. If you're using doors, same deal. If you're using metal sheeting, you can bolt through pre-drilled holes or use metal strapping. The goal is to create a continuous vertical surface that presses against the soil. Step 3. Internal bracing. This is where most amateur shelter builders fail. You need something pushing your vertical supports away from the soil, or they'll just tilt inward over time. Run horizontal beams across your shelter from wall to wall, connecting opposite vertical posts. These act like spreaders, maintaining the width of your space. Think of it like the poles in a tent, except instead of nylon, you're holding back several thousand pounds of malicious earth. Now let's talk about the ceiling, because a reinforced wall system is pointless if your roof collapses and turns your shelter into a very inefficient coffin. Your ceiling needs to span the width of your shelter while supporting the weight of all the soil above it. This is a beam problem. You need something strong enough to handle bending stress, which increases with both the span distance and the load. If you're working with wood, you want thick beams or joists running across the narrow dimension of your shelter. For bi-6 lumber at minimum, spaced no more than 2 feet apart. If you don't have access to proper lumber, you can bolt multiple 2x4s together to create a composite beam that's stronger than the sum of its parts. 3 2x6s bolted together create a pseudo 4x6 that's actually stronger than a solid piece because the bolts prevent the layers from sliding past each other. Lay your corrugated metal or plywood sheeting across these joists. This becomes your immediate ceiling surface. On top of this, you can add a layer of plastic sheeting for waterproofing, because the last thing you want is soil-flavored water dripping on you while you sleep. Then comes the backfill on top. You want at least 2 feet of compacted soil on your roof. But here's the trick. Don't just dump it. Layer it. 6 inches of soil, compact it by walking on it or using a tamper. Another 6 inches, compact again. This creates a solid mass rather than loose fill that will shift and settle unpredictably. We need to talk about drainage because water is the silent killer of underground structures. It adds weight, it destabilizes soil, it promotes rot, and it turns your shelter into a very sad swimming pool. First, perimeter drainage. Dig a trench around the outside of your shelter, below floor level, sloping away from your structure. Fill this with gravel. Water follows the path of least resistance, and loose gravel is much easier to flow through than compacted soil. This French drain system will redirect groundwater around your shelter instead of through it. Second, interior drainage. Your floor should not be bare earth. Dig down another 6 inches, lay down landscape fabric, fill with gravel, then place pallets or wood planking on top. This creates an air gap under your floor and gives any water that does seep in somewhere to go that isn't your sleeping bag. Third, waterproof your walls. If you can get your hands on heavy plastic sheeting or pond liner, wrap it around the outside of your wall reinforcements before backfilling. This creates a moisture barrier. It won't stop determined water, but it will slow it down significantly. Congratulations, you've built a sealed underground box. You know what else is a sealed underground box? A tomb. Let's not turn your shelter into a tomb. You need at least 2 ventilation points, one low for intake, one high for exhaust. This creates natural convection. Warm air rises and exits through your high vent, pulling fresh air in through your low vent. It's simple physics, and it keeps you from slowly suffocating or dying of carbon dioxide poisoning, which would be a really anticlimactic way to go after all this work. For intake, PVC pipe works great, 4-inch diameter minimum. Run it from outside ground level down to near your floor. Add a mesh screen on top to keep out insects and debris. Add a 90-degree elbow so rain doesn't pour directly down your air supply. For exhaust, same setup, but position the interior opening near your ceiling. You can use old, drier vent pipe, HVAC ducting, or more PVC. The key is making sure both vents are on different sides of your shelter to create crossflow rather than dead zones. Your shelter is not a finished project. It's a living system that will shift, settle, and try to kill you in slow motion if you let it. You need to monitor it. Check for cracks in your walls. Small cracks are normal settling. Large cracks or cracks that widen over time mean structural movement, and you need to add more bracing immediately. Check for water intrusion. Any moisture on your walls means your drainage isn't working properly. Fix it before it becomes catastrophic. Check your ceiling joists for sagging. A level or straight edge across your ceiling will show any deflection. If your beams are bending, add more support posts underneath them before physics teaches you a painful lesson. Listen to your structure. Creaking and settling noises are normal for the first few weeks, as everything compresses into equilibrium. Loud cracking sounds are not normal and mean something is failing right now. Here's the thing about building underground with scrap materials. You're not just building a structure. You're negotiating with physics, geology, and the fundamental nature of entropy. Every choice you make is a compromise between available resources and ideal engineering. But that's okay. Humans have been building underground shelters for thousands of years with materials that would make modern engineers weep. We've used stacked stones, woven branches, animal bones, and packed snow. The principles remain the same. Create a framework that distributes load, keep water away, and don't let gravity win. Your shelter doesn't need to be perfect. It needs to be functional. It needs to keep the earth where the earth belongs, which is outside, and keep your space where your space belongs, which is inside. Everything else is just details, so go forth. Reinforce your walls, brace your ceiling, dig your drainage. And remember, the best underground shelter is the one that doesn't collapse on you. Set your standards accordingly. Stay safe down there, and maybe invest in a structural engineering textbook. Or at least a good flashlight for when you're inevitably doing emergency repairs at 3 in the morning because you heard a suspicious cracking sound. Good luck, you're going to need it.